name is Anmol. I am the managing director at Sudan Tech. So it's nice to meet you all here. So today we will have Sachin Tomar. He is the CTO of Biconomy. So I guess he doesn't need that much introduction. He's quite famous. So yeah, over to you, Sachin.
Thanks, Anmol, for the introduction. Let me start off by sharing my screen. One second. Let me know when you see it.
Yeah, we can see it.
Yeah, it's visible.
Awesome, awesome. So in today's session, I'll be covering about blockchain. Starting with its history and what blockchain is actually is. Why should we use blockchain? How does it work? And everything about blockchain we need to know. And then at the after this, I'll cover how Biconomy is improving the space. In terms of user experience, and is trying to make this blockchain technology mainstream, so that everyone should be able to use blockchains. uh, so initially, why a blockchain is needed at all. What exactly is this blockchain? Why we should use blockchain? So mainly, why blockchain came into existence was there was no sort of system, I would say, where there is no central control or of that particular system. Everything before blockchain was being run by some centralized party, and there were few people, or a company who is actually taking the major decisions of that particular platform. And the actual people who are using that platform, they did not have a say in the platform itself or the network itself. So there was this need, and that actually is hindering a lot of use cases before blockchain. For example, if you want to, let's say, transfer some sort of money from one bank in America one into one bank in India, we in today terms we call them like remittances. You want to move money from one country to another. There are a lot of parties which needs to be involved in order for you to get your money from one country to another. And those centralized parties or banks are actually making decisions for you, that this is the fees which you need to pay. And then there are multiple hops, there are multiple approval that needs to be given in that whole system. So this whole sort of centralized system were preventing you know I would say many use cases before, so that moving money is not easy, it's costly across different countries. So there was a need for a system where there is no central a party that actually decides anything in that particular platform. And that's why blockchain, the concept of blockchain actually came. It's a blockchain is actually nothing but a network of nodes. There are different servers or nodes people are running, and they are all combined together by some protocol. Whatever code that node is running, that code is actually making sure that they all together combines and make a network. And then people can actually do some sort of activities on that network, and all the rules of that particular network are written in the code itself. There is no external person or third party that enforce these rules, or there is no centralized entity that enforce these rules, but everything is written already in the form of code. And there are multiple nodes that are running that particular code, and that code actually governs everything. It decides how a network should perform, how people should be allowed to participate in the networks. And in terms of blockchain, how blockchain should actually evolve. And once the network is live, there is no single person who can actually say that I want to change this, let's change this. There is no single person who can actually change anything. So that's why blockchain, that's what blockchain bring. They bring this concept. and it's an open network, so that there is no permission. You do not have to ask someone to for permission to be a part of that network. These are open networks, where everything is governed by the code itself. Whatever is written, that will happen. And that's the main concept of the blockchain. uh, Now what, like, as we are building these open networks. Let's say we have built this one blockchain, where we are asking people to become a part of the network, and then make the network like more strong. Because the more people you will involve in the network, the more decentralized that network will become. So, but the question comes, like, why would people do it? What's in it for them? So usually, if you are let's say doing something for in a company, if you're working in a company, it pays you money. That's why you are working in that company, right? So everything you are doing for society, you get something in return, for your efforts. And that's what motivates you to be a part of any network, be it human network or society or any network. And that's what blockchain also implement, in order to bring more participation, so that more people can actually join the network. The blockchain also, this network also rewards them with something. So and that something is actually what we call tokens in a blockchain space. So tokens, you can consider them a digital currency of that particular network. And it can be rewarded to these different actors in the blockchain for providing, maybe some are providing their computation power, some are providing their let's say internet bandwidth, or some are providing their storage to the network. So, and some are providing security to the network. So these sort of inputs from actors are actually rewarded by the network in terms of token. So that's why people would be like incentivized to be a part of the network, and then run the network, and make it like more decentralized. And that's how any blockchain, actually that's how any blockchain works. If you take Bitcoin, Ethereum, and even whatever other layer 2 blockchains are coming, there needs to be an incentive mechanism for the people to be a part of the network. That's the basic concept of blockchains. uh, Now, if we see these terms, you must have came across these terms, web 2 and web 3, if you have explored blockchain space. uh, so everything, web 3, you can consider a space that's a like new technological innovation, you can say, where we are creating open networks and decentralized network. Where there is no trust assumption. We do not have to trust a single company, or we do not have to trust let's say some persons. And anything that provide this decentralized network, where there is no trust, where everything is governed by a piece of code, that space is what we call web 3. In web 3, like, only blockchains does not come in web 3 space. Blockchain is a part of web 3 space. There are decentralized storage solutions also, that are different from a blockchain, that also comes in web 3 space. And everything that is before that came before web 3, where we have some sort of centralized entities that they are controlling these platforms. If you take an example of platforms like Facebook, Twitter, or any Uber. So these are the web 2 applications, where there's a company behind it, and they control what happens on that platform. So this is a difference between web 2 and web 3. And since web 3 is still a new space, there are a lot of challenges that are still needs to be solved in the web 3 space. So more people are inclined towards web 3 now, just because it is it's an exciting space to work in. It has never been done like this before, where there is no there's no one controlling it. controlling the network, and all the people are actually together, coming together and running a particular network. So that's also a very challenging and exciting in itself. And that's why we are seeing like a lot of movement from web 2 to web 3 in terms of developers today. Now we have talked about the network itself, but now there is a network where we have set some ground rules, that these are the rules that this network should run. But now comes the parties, like the user of that network. Now we say that there are nodes, people are running nodes, running the network, but who is actually using that network? So it's the end users who are using this network. And then there will be some developers who will build application on top of that network. So these, like all the applications that are built on the built on web3 based technologies. So mostly it's based on blockchains. So you can say like all the application that are built on blockchain are called decentralized application, and in short we call them dapps. So uh, like how does a dapp actually work? I'll give you an analogy with a normal web 2 application. So traditional web 2 application, for example, let's take an example of Facebook, right? So Facebook has a user interface, which we call front end, where end user comes and interact with the platform. And then Facebook will have a backend servers, which Facebook company itself is running. And then they will have some sort of databases, and then there will be some APIs using which a front end and backend are connected. So that's how a normal web 2 application typically works. And that front end can be a browser based interface or a mobile based interface. uh, that's a traditional web 2 application. But if you are building a decentralized application, the basic things which you need is your like the way the backend is being run by these companies, in web 2 space. Here the blockchain itself act as a backend. So you do not have to run these backend servers. You can just write your code and just deploy on these blockchains. So these blockchains have a way for you to write any your custom logic program. Like you write this backend system in Java or JavaScript, in Node.js or Go language. Blockchain, each every blockchain has their own language for writing the business logic or the code. And those things are which we call smart contracts. So smart contracts will have some programming language in which you can write these smart contracts. Again, it's actually a program, like program only, software only. If you are a good programmer, you can learn these smart contract language and write these application in the form of smart contracts, and you can just deploy these smart contracts on the blockchain, and that will act as your backend. And on the front end, it's the same technology which we are using in web 2 space also. You can use any front end based framework, Angular, React, or even a basic normal HTML, JavaScript, CSS. You can use this to create a front end. And then now, instead of connecting that front end to the back end, you can just connect the front end to directly to the blockchain. And your decentralized application stays on chain, and there is a front end user are coming on the front end and directly communicating with the blockchain itself. And that's how decentralized application work. The good thing is, since your application is actually on the blockchain, and there are number of people running these blockchain nodes, so eventually every node would end up storing your application logic also. So it will never go down. You do not have to manage a backend server. You do not have to keep it like up and running all the time, because blockchain is doing it for you. So that's the main advantage of decentralized application, that they are never down. uh, because the smart contracts is being run by a number of people in the blockchain. And on the like there are other components on the front end which you need in order to interact with the blockchain directly. There are so let me see if the yeah I'll explain it here only. So the way you use, you need to create some identity of yourself on a platform if you want to use that platform. For example, on Facebook you create your account, right? That's your identity, that is tied to your email and password. On blockchain, uh, you know there is no such thing called username and password, but instead of those we have addresses, which we call them there is a, if like your representation can be one address on blockchain, and like your address is consists of one public key and one private key. So you can consider public key as your email address, and you can consider private key as the password, if you compare web 2 to web and web 3. Now these the good thing is you do not have to register somewhere to get these public key and private key. It can actually be generated by these cryptographic libraries. You can randomly generate any address, and that private key also will be provided to you by that library, and that will be your identity on that particular blockchain. So you do not have to go anywhere to generate your account. You can even generate your address off chain, like offline also. You can just download these cryptographic libraries which generate these addresses for you. So there is no like dependency on anyone for you to create these addresses. And once you have this address, there are front end application called wallets that actually manages these addresses for you. So if you want to create a front end for a blockchain based application, you need a wallet, to connect, to manage your, identity or addresses on chain. And using that wallet, you can actually, you actually interact with the, blockchain. Uh, and if you see the already the landscape of the dApps, like there are already different application on the blockchain that has been built so far. And there are different categories of it, like DeFi is called decentralized finance. So all the financial based application on the blockchain are called DeFi application. There are gaming application on the blockchains. There are NFTs is a recent term that has been gaining popularity. So if you don't know like NFTs, uh like I won't go like too much into NFTs right now. Just I want to cover the basics in this presentation. But yeah, NFTs are some sort of, you can say, asset that is present on the blockchain. And just like tokens are there, NFTs are also some assets that is unique in itself. And then gamings are there and different types of applications. So once you explore this space, you will get to know what all different things you can do. But majorly these types of application are gaining popularity. There are some like social social network platforms that are being built on blockchains also. So you can actually explore these different applications. I think this we have covered, like why blockchain was needed, because there were these problems in the centralized application. Even if Facebook wants to delete something from your account, they can do that. Even if you are posting something on Twitter, and if Twitter thinks that it should not go out on the platform, they can actually censor your tweets. They can delete your tweets. They have the end power to decide what goes onto their platform. And if and yeah, if that platform goes down, then there is a central point of failure. And there's like too much control in the centralized platform. That's the problem that the decentralized application are solving. And if you talk about like how this whole ecosystem of Web3 ecosystem evolved, blockchain ecosystem. So initially, even before Bitcoin came, so Bitcoin was the first most popular blockchain that that made this blockchain concept famous. And before even Bitcoin was there, there was this system called Hashcash that was actually built on some cryptographic logic. And uh, and uh, they were trying to solve this problem of email spam. So they tried to solve it using cryptography, where there will be some costs associated whenever you are sending an email. And the sender of the email can actually be verified cryptographically. And whoever those sender who are not verified, we can consider them like spam, for example. And then if you want to like send too many emails, then there will be some cost associated with it also. So they tried to solve it using Hashcash. And then so that was majorly focused on email spam filtering. But then this Satoshi Nakamoto came with an concept of Bitcoin. So it's a decentralized blockchain that only deals with the movement of value on Bitcoin network. You cannot do like anything else. But Bitcoin is the currency in the Bitcoin blockchain, and you can just move Bitcoins from one account to another account in a decentralized way. So it became famous, and people were able to move their Bitcoins, even if someone is in Germany, and even if he wants to send some Bitcoin to someone in India, they can do it very quickly, because Bitcoin blockchain is run across the globe. There is like no country barrier to it. And that's why that's what made it famous. And no one could actually tamper with the data that is actually present on the blockchain. So if you just see these stats, like on 9th January 2009, that's when first block in Bitcoin blockchain was mined. And whoever created that block, he was rewarded 50 Bitcoins at that time. And then the popularity of Bitcoin led to a new blockchain called Ethereum, that was built by Vitalik Buterin. And he came up with the idea that why not use blockchains for doing any arbitrary for executing any arbitrary business logic. Why just limit it to movement of value? And that's what led him to build Ethereum. That's a general purpose blockchain, where apart from moving the native currency, you can also write any custom business logic on chain. And that's what we call smart contracts. You can write any general purpose smart contracts on Ethereum chain and run it. And even you can create any custom currency on chain using these smart contracts only. And that's what make Ethereum so popular, that it's a general purpose blockchain. You can build literally like anything on this blockchain. And then of course, like, there were some shortcomings of Ethereum. It was it has become like too expensive to use, because if you see, whenever we are interacting with the blockchain, we need to make a transaction on the blockchain. And that transaction actually does some state changes on blockchain. And those state changes, if you want to do, you have to pay something. You have to pay a fees in order to do that. And this was done, like, the transaction fees actually introduced to prevent the spam, or you can say DDoS attacks, to prevent these things. Because if there was no cost, then many people would be sending a lot of transactions to change the states. And the whole network will be clogged. And to prevent this, the transaction fee is actually introduced usually in the blockchains. And in case of Ethereum, it's very high right now, considering how the value of Ethereum is actually rising. which has eventually made Ethereum not to be used by, let's say, many people, because not a lot of people have like a lot of money to interact with this protocol. And uh, and it also has limitation in terms of how many transaction it can process, in uh, in one block. So, or how frequently, these blocks are created, so it is considered to be comparatively slow. But if you consider it in terms of security, so even Ethereum is, considered to be the most secure blockchain even today, just because there are a lot of people running the nodes of Ethereum. I think it's in thousands, people are running the Ethereum node across the world, and that's what, is providing the security to the Ethereum blockchain. And but again, like, it has their own shortcomings. To overcome these, other blockchain scaling solution, started coming. And right now, there are scaling solution, which we call them, layer twos. Some are called rollups, and their main purpose is to scale the Ethereum, where you can actually do a lot of multiple transaction on these layer 2 blockchains, where the cost is very low, and the transaction, processing speed is also high. And then these layer 2, scaling solution combine, multiple transaction, and then put all the proofs, of those transaction on Ethereum on a periodic basis. So eventually Ethereum is the final chain where the any data finality can be considered. But these layer 2 blockchains are providing faster transaction at a very, cheap price. So if we, deep dive into, just, see a transaction flow, like how a transaction is actually sent to a blockchain, like what happens inside the blockchain and how a state change is, being done. So let's take this example. If you see on the left side, you can see one user, shown by a laptop. Another on the right side, there is another user, right? So as I earlier mentioned, each user has its own identity on blockchain, and that's what we call address. So let's say, uh, like address A wants to send some currency to address B. So what A will do is, A will create a transaction. So, if you are, using these databases like, MySQL, MongoDB, so in those DBs, create a transaction or a row, and then, you commit to these DB to save them, right? So each transaction has their own format. Similarly, blockchain transactions have their own format. It's just a JSON, object that is actually cryptographically signed by a key, and then that is, sent to a blockchain. Now when we say that transaction is sent to a blockchain, to whom actually we are sending this to? So as you know, blockchain is nothing but a group of nodes. So you can just pick any of these nodes, and then send your transaction to that particular node. And since all nodes are connected with each other, whoever receives the transaction, they will just broadcast your transaction to every node in the network. And that's how, your transaction reaches the whole network. And uh, so once, the transaction is identified by all the nodes, after you send it to a single node and then it is broadcasted to all other nodes, uh, that transaction is actually cryptographically verified by these nodes, and it is, checked against the latest state of the blockchain. So uh, once that is matched, as per the latest state of the blockchain, your transaction, whatever transaction you have sent, and, every node, find like no error in that. Then, so one of these nodes will actually create a block in a blockchain. And like a block is just a, concept in the blockchain where, transactions are grouped, and eventually the state is changed from one state to another after that block is created. So it's nothing but state changes that are happening on chain. And once your transaction is included in a block, it is executed, and the latest state of the blockchain changes to some other state, right? And each and every node in the blockchain then agrees that okay, this is the new state, now we should keep. And every node's update its local state by that new state, and that's what becomes the latest state of the blockchain. And now once that is done, now B, the like A is money moving to B address, right? Now B address can actually query the latest state of the blockchain. And if you are transferring some money, so according to latest state, the balance of address A must be now reduced and balance of B must be increased now. And that's how you are moving money on a blockchain from one address to another. So if you see, it's all at the end of the day, it's all about state changes on blockchain. And every node is actually verifying that a new state is actually whether it's a valid state or not. And that's what these nodes are actually doing. And by every block, we are changing the state of the blockchain. And these nodes are actually rewarded by the code itself. So whoever is creating the block, it will be given some tokens as a reward. And that's what keep them motivated and keep running the node in the network. And then like keep on producing these blocks and executing these transactions which end users are putting on chain. And that's how a blockchain is actually working. uh, so there is usually a problem which we need to prevent, that's called double spending. We don't want that that if you have like 5 bitcoins, it should not be like you should be able to send 5 bitcoin to another address and 5 bitcoin to another, because you can just only send to one address, right? So that's also is checked by the blockchain, that you cannot eventually double spend your money at any point in the time. And if you try to do it, the blockchain will actually reject that state changes. Again, it's all about state changes. uh, it will not be accepted by the network, and your transaction will be rejected if you try to do a state change that was not allowed by the network. uh, this is just a representation of different blocks. You can see this block 20, 21, 22. Each is having some transaction, and each transaction is actually changing the state of the blockchain. And all transaction needs to be valid state changes transaction in order to be executed successfully. And then this goes on, new blocks are getting created on blockchains. uh Features I have like told you, like the blockchains are distributed, immutable also. So immutable in the sense that if one block is created, you cannot go back from this block to block 20. The whole code of the blockchain is written in a way that it can only move forward. And once some state changes has done in a particular block, you cannot undo it. That's the property of the blockchain that makes it immutable and irreversible. The peer-to-peer network, in a sense that every node is connected to each other. And whatever information one node gets from outside world, like if I am a user, I'm using blockchain, I send some information to one node, it immediately broadcasts that information to all other nodes in the network using peer-to-peer communication protocols. Tamper proof, because everything is being validated cryptographically, and everything is done by the code itself. So you cannot tamper with any blockchain data. So it's not like if I send a transaction to a blockchain, I am signing that transaction with my private key. And like if some miner, if some node in the network who is producing the block and putting my transaction in the block, he it cannot change anything in that transaction, because it is actually signed cryptographically. And cryptography is actually providing this security, that the data, whatever data I'm sending, is tamper proof, and no one else can actually change that data because of the cryptography that is being used in the blockchain. uh, this is also like covered, like the immutability is there. Whatever data you put on chain, that is immutable. Consensus is there. So consensus is like all the nodes in the network are agreeing on the validity of transactions. So every node says, okay, now this state change is actually a valid state change, so let's put it in the block and carry on with the network. So a consensus needs to be there in all participants of the network, and that's what keep a single blockchain flowing. And if you can say that some nodes might not agree to something, and some nodes will agree to some other things, that can actually happen. And that's what we call blockchain forking, where some node says that this thing should be done in this way, some nodes says that no, this is wrong, we should do it this way. So eventually they will create their own blocks, and they will create their own blocks, so the state will be forked, and there will be like two blockchains it will emerge from a single blockchain in terms of state. And eventually whatever is the longest chain, or longest chain in the sense like wherever there is majority, that chain will eventually be the longest chain in terms of new blocks will be created more frequently over on that particular chain, because majority is over there. And eventually we will consider that as the final state of the blockchain. So these things do happen, some forking happens, and then eventually wherever the majority is we will accept that thing, and that eventually there will be single final state on the blockchain. And that's the finality. And the provenance, like anything you are doing on chain, you should be able to prove it on chain. And again, all the cryptography is being used here to prove that you have done something on chain. Now if we talk about types of blockchain, mostly what I have talked about is are public blockchains, where there is no permission needed for you to be a part of the network. And there is some consensus or agreement on something that needs to be there. That consensus can be like of different type of consensus are there: proof of work, proof of stake, delegated proof of stake. I will not go like too much into it, but yeah, some sort of consensus needs to be there in public chains. And it's open to everyone, like anyone can access the data, anyone can write the data, given that that state change is actually a valid state change, and you are actually paying for that transaction. But there are private blockchains also, where it is permissioned. If you see the difference here, public and private, access is open to everyone in public, but in private chain access is permissioned. You need to take permission from some entities in private chains to do transaction on that blockchain. Considering it's an open network, usually public blockchains are slower, and private blockchains are even faster, because only few entities are actually controlling the blockchain. And then security, again security comes with these consensus algorithm. And then in private blockchain, it's up to them, like up to few nodes, they can actually decide like how to secure the network, and they can restrict people to do the transaction. And that's why that's how they are adding security to this private chain. So I'm not like a fan of private chains, to be honest, but mostly I just want to work on public chains, because again, like private chains can be useful in some scenarios where it doesn't need to be a public chain, because the data is actually not at all public at all. But we just want to put let's say there are three entities, and they just want to do everything uh, by the consensus of all three of them. So they can start their own private blockchain, and they can decide what data should go on the chain. But mainly public blockchains are mainly famous in the blockchain world, and that's where you majorly the work is being done. Smart contracts, I've already told you, you can write these programs on these public blockchains, and they're called smart contracts. And how to use blockchain, as I mentioned, a wallet is needed to manage your account, manage your identity on chain. A connection to any node in that blockchain network is needed, where you will send that your blockchain transaction. Blockchain account is actually managed by the wallet itself. So account is needed because you need to sign the transaction. And then, as I mentioned, there is a transaction fee associated to it. So you need to have that balance in your account. You need to pay for that transaction fee. And then there are some other, other information you should know when you are sending the transaction, like how much price, how much transaction fee I should set. If I want to, if I want this node to actually include my transaction or execute my transaction and put it on chain. So there are, you see, it's quite complex actually to use the blockchains right now, because even though the custody is with you, you get to decide what happens with your account. But then again, there are these different complexities. You need to learn what is gas, what is gas price. You need to keep this balance in your account all the time to pay for the fees. And that's what Biconomy is actually solving this problem. Even though it's a good technology, it's very complex right now. How you should be using the blockchain, just like how you are using normal web 2 application, where you just create your account. You want to tweet something, you write a tweet, click tweet button, and then it goes on the platform. There is no fee as such. You do not have to worry about how Twitter backend works. Like you do not need to pay for those transactions. And that's how a blockchain application also should be used. And that's what Biconomy is uh, solving these problems by building the infrastructure. So we have built a transaction infrastructure where instead of that is actually abstracting away all these blockchain complexities which I mentioned here. So uh, where if a application developer is building an application and users are coming to it, they just provide their signatures from the wallet. And providing signature does not cost you anything. And everything is handled by Biconomy's infrastructure behind the scene. We are dealing with the blockchain connections. We are dealing with signing a blockchain transaction, paying for the fees, and then end user should not be concerned about that. And that's what we are doing. If you see how early we are in the blockchain space, uh, you see Gmail, or even this Microsoft platform, they have like billions of daily active users. uh, but if you see on blockchains, so far around 136 million addresses, or you can say accounts or users are identified. And active users out of them are just around 500K across all dApps, and this is on Ethereum we are talking about. So you see 500K and 2 billion, and these 100 million daily active users, there's a huge gap. And we just need to remove these frictions whenever you are dealing with blockchain. And if we remove, like, we believe that if we remove these frictions, more users will come into this space. More user will adopt this blockchain technology, and then this number will actually grow. And that's how we will be able to achieve like mainstream adoption of the user of the blockchain technology. And that's what we are also targeting towards. Mm, this is nothing but all the complexities that I talked about related to blockchain. So even though your UI is very sexy, but the black back end of the blockchain is still very complex. You still need to go through all those complexities. You still need to pay transaction fees. You still need to know about the gas fees or gas price, or what transaction fee should I put. So all of these are needs to go away, or not go away, but they needs to be abstracted, right? uh, that's the goal, of the next generation of these dApps, that we reduce the number of steps to interact with this blockchain, make these crypto uh, tokens or technology more accessible, and then more chains are coming. So it's not just Ethereum blockchain, other blockchains are also coming with their own set of pro and cons, and each blockchain provides a solution to maybe a specific solution, right? A specific problem. So, and then there will be cross chain communication integration that are that's the next generation development, which we are expecting in the blockchain space. And then more use cases in the real world scenario using the blockchain, but in a frictionless way. We need to reduce the friction to use these blockchain application, and that's the only way to make this technology like mainstream. uh, so Biconomy, as I earlier mentioned, we are simplifying the blockchain experience for the end user as well as the developers. So we have built this infrastructure where we have SDK and APIs for dApp developers to use. uh, if they want to just send blockchain transaction in a very easy way, they can use our APIs and SDKs, where we will abstract away all the complexities, and their user will get to enjoy uh, easy and frictionless experience, and at the same time get all the benefits of the blockchain technology. This is so as I mentioned, that we have this SDK and APIs to easily send blockchain transaction on one chain. And then since more chains are coming, so we have like another product that is actually solving these cross chain transfer of funds. So you can easily move your funds from one blockchain to another. Polygon is another layer 2 blockchain uh, that is solving the slow transaction problem or high fees transaction problem. But still, people, it's not like people are not using Ethereum because of the high fees, because it is the most secure blockchain. So people usually want to keep their assets on Ethereum only. So still, there needs to be a solution around communication across these chains. So this is a product which we Biconomy has built to easily move these funds across different chains. And if you want to like know more like what Biconomy is doing, if you are developing an application and you want to reduce these friction in your application, just check out docs.biconomy.io. You will get to know like what how you can actually reduce that friction in your application and abstract away all these complexities of these blockchain transactions. I will share this link in the chat if you want to go through this presentation, and I will take the questions now.
Sure. There are quite a few here. Many basic, some interesting. So the first question is, what are tokens? Please explain a little more in detail.
Okay. So tokens are digital currency, you can say. Uh, so when a blockchain is created, one currency is inbuilt in the blockchain, and that's what we called native currency of that blockchain. So that is the code for that, the rules for that token is already written in the protocol itself, in the blockchain code itself. Now if you see Ethereum blockchain has the native currency called Ether. So that the code for Ether currency is already written in the blockchain protocol. Now Ethereum allow you to write these smart contracts, and you can actually write a smart contract that represents a token on Ethereum blockchain. uh, Anyone can write, even you can deploy a smart contract on Ethereum that is actually a token smart contract, where your token rules will be written, that uh, using a function in your smart contract you can transfer that tokens. There will be this much supply of this token, like there, for example, there will be, let's say, 1 billion token only that can be available at any time in the Ethereum blockchain. So they are called tokens. It's nothing but just a smart contract with some set of rules that allows you to transfer these tokens. And or even if you want to mint more token, you can put that functionality in your smart contract. If you want to burn any tokens, you can put that functionality in your smart contract. So it's up to you. It literally is a smart contract deployed on chain. And oh, and now you will ask, like, how will it how it is valued, like where the value will come from. So value actually does not come from like anywhere from the code itself, but it's how the community or the other people actually perceive the value of that token. So it's the people who are deciding what value a token should be given. If you are talking about ether, you can see the prices in these exchanges. Ethereum prices is going up and down. So who are actually driving these prices? It's the people, it's a community who are actually using these tokens. So the more demand for a token is, then the more high its price will go. It applies to any industry, be it blockchain, be it normal financial industry. But yeah, that's what a token is. To answer your question, it's just a smart contract with a set of rules. And once you deploy it, once you get it on blockchain, you can ask people to transfer those tokens, or use those token in other applications. And then that's how a token utility comes into play. And that's when people start trading that token, that's when the value will be associated with that token.
I hope that answers your question, Ramesh. One more question. I saw this repeat in two places. So, what is Web 1, Web 2, and Web 3? So, they want to go to the very basics.
Yeah. So web 1 was even before these dynamic websites or application like Facebook, Twitter came. Before that, there were some static websites only with some information that is hosted on a website. And you cannot just do any interactivity with that website. So that era is called web 1, where it's just static websites hosted online. And then web 2 came, where the internet became like more interactive. People started to interact more with the internet and application built on internet. And then any internet based application, you can say, comes under web 2, web 2.0. And then any application that is actually built on a decentralized technology or any blockchain, you can consider that as a web 3 application, if you are talking from the point of view application. Yeah.
Okay. What will happen if all crypto gets exhausted?
Okay. So this is a interesting question. So crypto, like what is a crypto? We call these tokens or currencies, we call them all together as a cryptocurrencies, right? Now, as I earlier mentioned, a token is nothing but a smart contract on any blockchain, or a blockchain has a native token in itself, where the code is inbuilt in the protocol. Now you can actually decide whether you want to keep a fixed supply of that token or not. For example, Ethereum, the native currency does not have a fixed supply. At every block, some ether is actually minted out of nowhere. And that's how supply of Ethereum is actually increasing. And again, protocol can decide whether to keep on increasing the supply, or whether to burn the tokens. By burning token means we decrease the supply eh, in the market. So the only way to exhaust all the crypto is by burning all the tokens. And there is no mechanism to mint new tokens. That's when all crypto gets exhausted, and there will not be any digital currencies. But that is not going to happen. because you cannot just burn all the crypto token, because it's not in one hand. It's actually distributed with many people, and there are many utilities of those tokens. So you just keep on transferring the value. You just keep on transferring the crypto from one person to another. You are not exhausting these crypto. So that's how activities are going on. Crypto tokens are going from one address to another eventually. That's what's happening.
Another question about the government. So does the government allow blockchain to operate?
Again, we like the main advantage of blockchain is they do not need any government permission to run. It's a decentralized application. If you see, Ethereum blockchain, for example, I mean, you must be hearing about, Indian banks saying that, you should not deal with these cryptocurrencies, otherwise they can take some action, on you. So that is specific to India or Indian government, right? Uh, no, like if you there is no, like, they cannot stop Ethereum blockchain. Indian government cannot stop Ethereum blockchain because it is decentralized. It is not being run by Indian government or any Indian entity. That is like worldwide people are running the blockchain. And it's not up to them to allow blockchain to operate. Yeah, they can create new rules in India that you need to abide by because you are an Indian citizen. And uh, and that's but in the tech at the technological level, they cannot stop the blockchain or stop you from using the blockchain. And again, blockchain is not just about token transfer only. There are other there are other usability of the blockchain technology. You can build a social networking platform, or decentralized messaging platform on blockchain, where you are just passing messages. There is no you doesn't need to deal with these cryptocurrencies if you are building this application on blockchain. So those are two different things you will get to know once you know more about how application and what different applications are being built on blockchains.
Okay, this is a follow-on question on to the exhausting all the crypto. So
Okay.
I would say it doesn't really make sense, but I'm just going to read it out. How will blockchain companies earn when everything is exhausted? So I think we can dismiss that, looking
Yeah.
at the question that you answered earlier.
Yeah.
Please explain the difference between a centralized system and a decentralized one.
So a centralized system is a system where the power or control lies within few entities or a single company. Uh, uh, for example, the Google account, for example, if you are using Gmail, if tomorrow Google wants to shut down the Gmail services, they can do that. They have the control. Then that is the centralized system, because one entity has the control over a Gmail application, for example. A decentralized one system, uh, again, let's take an example of email, right? If another email system is actually built on a blockchain or a decentralized technology, there no single entity has the right to shut down that platform. And that's what we call a decentralized system, where no single entity has the power to uh, shut down that system or to change anything in that system. uh, that decentralized platform is actually being run by multiple people, not just a single entity. And yeah, I mean, if all the people running the network decides to take some action or shut down that particular network, they can do that. But again, they all will need to be agree on something. And that's what a decentralized network is, or a system is.
Okay, next question. How or where is the blockchain stored?
Okay, so yeah, I mean, I see this question many times, and yeah, there might be some confusion on how it is actually stored. So, a blockchain is it's a network of node. So when we say network of nodes, there are, no blockchain node, there is a code written for the blockchain. If you want to run a blockchain, you can just, there is a get, we call it get node. uh, you can just search it, getting started with get. This is a code which every node in the Ethereum blockchain is running. So this is a piece of code which, some people are running on their servers, and they are just getting connected with each other. uh, and that's how a network is formed and a blockchain is formed. Now what a blockchain data is, uh, every node is actually storing a blockchain data. So it's not, uh, some sort of, uh, a new concept or anything new. It is a local database where the data is actually stored, but that same data is stored in each and every node. And if you want to access the blockchain data, you can just get connected to any one of the node and read the local state which they have on their, local system, because that same state is actually saved on each of the blockchain node. So you can just, read that state, and if you want to sure that it's a correct state, you can read the same state from multiple nodes and compare them. And if you see the same state, you can consider it that this is the final state of the blockchain. So it is stored in each. So to answer your question, blockchain data is actually stored in each of the nodes locally, and you can just access them, by connecting to that server. And they can actually use a local database, to save that. Maybe they can use, the graph, database, or MySQL database if you want, or MongoDB locally. And there the blockchain data is actually stored locally. And the way that, data is updated is based on the, blockchain transaction that are coming. So every, let's say a blockchain transaction comes, you will execute that blockchain transaction. There will be some state changes to your local data. You will verify cryptographically whether it's allowed or not. And if it's allowed, you will change your local state, and you broadcast that local state to every other node in the network, and every node will update its local state. And that's how, a blockchain data is eventually is updated in every node. And that's how, state changes, happens on the blockchain.
Okay, someone is asking if Biconomy is hiring blockchain developers.
Biconomy is hiring. Yes, we are looking for blockchain developers. So if you are interested, you can actually send an email to connect@biconomy.io, or just reach out on our Discord servers. Just go to biconomy.io. You can find a contact us information. Just send your interest over there, and then we'll, check that out.
All right. One more question. Okay, quite a few actually. If you don't have the time, Sachin, you can let me know, and we can close it off or get people on stage to quickly kind of go over some questions, because there are 2 or 3 people, and there are new questions that are being added. So, do you have the time?
I can spare 5 more minutes. Yeah.
Okay, sure. How will banks work if blockchain rules the world?
So, I mean, if blockchain rules the world, banks might be obsolete tomorrow, to be honest. If everyone decides to use blockchain as the final storage of your, digital currency, then yeah, like there is no use of banks. But like, this is not an easy thing to, do. Banks have their like own advantage, because in blockchain, if something goes wrong, there is no one you can actually reach out to, uh, to ask for any help, because it's a decentralized network. There is no single owner. That's what can be considered as a disadvantage of blockchain also. You are trusting the piece of code only, and if someone is able to find some loopholes in that code, you have nowhere to go actually, to complain or ask any help. But again, like banks have a centralized, entity. They are responsible for everything that happens. You can actually reach out to them with your own problems. But again, like this shift of using, banks or centralized entities to using decentralized applications, it will happen gradually. And it's not like you have to move everything on blockchain. It doesn't mean that every centralized or services have to be used on blockchain. Only those should be moved to blockchain where you need to remove the trust factor on a particular entity in between. uh, and where you need to have the ownership of your assets of anything by your own. Where you need to remove the dependency of like for the ownership, you do not want any other person to control your things. Those are the things that should be moved to blockchain. Not everything doesn't need to be moved to blockchain.
Okay, someone's asking if Biconomy is going to launch its own token. So, I mean, he said Bitcoin, but I'm assuming tokens.
So yeah, so Biconomy's products are right now running in a centralized way, just to because we believe in a progressive decentralization. And now, since we have clients, we have people using our products. Now we are moving to a decentralized infrastructure. And we are going to launch a Biconomy token that will actually act as a security for our own network. And then it will actually bind all the actors or activity that will happen on Biconomy decentralized network. So yeah, we will be launching.
One more question about Biconomy. When do you plan to integrate all the networks into your project?
So we already support quite a number of blockchains in Biconomy: Ethereum, Polygon, XDAI, Binance Smart Chain, Moonbeam, that's Polkadot ecosystem, Arbitrum, Optimism, we are going to support soon. So, wherever the demand comes, we will support that blockchain.
Okay, this is a question for an aspiring engineer, a blockchain engineer. So what is the minimum requirement or technical knowledge that you need to start a career in blockchain?
So if you are a good programmer and you can learn, different technologies very quickly, that being a good programmer is enough to start the career in the blockchain. uh, it You might take some time to wrap your head around how decentralized network actually works. So I would say you start reading the white paper of these blockchains. You start by reading the white paper of Bitcoin, and then you move to white paper of Ethereum, and then you will get to know the basic concept of a decentralized network. And regarding writing the programs or smart contract on these chains, it's just about learning a new language. That's all. If you are a good programmer, you understand the programming concepts, it will not be very difficult for you to learn these things.
Okay. Someone's asking if you can tell a little more about private blockchains.
um Private blockchains, I haven't seen like many private blockchains in action. And they like, as I said, in public blockchains, anyone can actually join the network. In private blockchain, there are some permissions, that whoever is starting that private blockchain, they gets to decide who actually can interact with that blockchain, who actually can become a node in that blockchain. And so it's all very restricted kind of blockchain. But since basic properties of the blockchain are, it is immutable, it is trustless within the within all the within all the parties that are running the blockchain. So if let's say there are three companies, The three companies have their like own data, own transaction, and they decide, and somehow they are related, and the three companies decide, okay, we cannot trust you, we cannot trust your company to do transactions on behalf of us or something like that. They can actually start a private blockchain where only they can post transactions. But if one company is posting transaction, other two companies are also seeing that, because only those three companies are running the blockchain, they have access to the data. So within them they can be sure that they do not need to trust each other, and a blockchain properties are allowing them to run a private blockchain and making sure that whatever data anyone is putting, anyone can see that, and it can be validated cryptographically. So a company cannot put wrong data on the blockchain. So that you can consider as a use case of a private blockchain.
Okay, last two questions. Does blockchain have any kind of rules or any kind of security? I'm not very sure what that means.
uh, so blockchain has again, a blockchain is just a piece of code that every node is running, and that that code, like what is a program or what is a code? It is a set of rules only, right? If you are writing an addition program, you are writing a rule that if you pass one parameter and second parameter, the third, the actual logic will return the sum of that, those two parameters. That's kind of one rule, right? So similarly, different rules are being written on code level, and every node or every person who is running a blockchain server, that is just running that piece of code, and those are the rules which everyone is running. And that's what is providing the security also to the blockchain. So if someone try to post any data on blockchain that is not intended to go, other nodes that are running the same code will be able to identify that this is an invalid transaction someone is trying to put, and other nodes will actually reject that transaction. So you as a single node cannot put arbitrary data on blockchain, because it is being validated by every other node in the network. And that's how a security of a blockchain comes, that every activity is validated by every other node in the network.
Okay, last question here. Is it possible to merge all cryptos like Bitcoin, Ethereum into one?
I would not say that this
Yeah,
would be
I was.
possible.
Yeah.
Yeah, because see, Bitcoin is a different blockchain that is running a different set of rules. Ethereum is a different blockchain that is running a different set of rules. So they are actually designed in a way to be run independently, and that's how they are able to validate each and every other transaction, because every Ethereum node know what the protocol is, what type of transaction should come, what type of validation should be there. Bitcoin has their own different set of rules. So I would not say they can be combined, but tomorrow you can create a new blockchain where you might be putting some part of Bitcoin blockchain rules and protocols, some part of Ethereum. If you want to put, you can actually create new chains, but yeah, not combining these two existing chains.
Yeah, I think we've covered all. There's one more, but I think we can close this session. Otherwise, it's going to keep coming up. Anybody who has more questions, please feel free to get on to the Discord channel. We'll be sending you a link to the Biconomy Discord channel. You can reach out to Sachin and the larger team there. They'll be happy to answer any further questions you may have about this subject. All right. I think I'm going to hand over the mic to Anmol to just give a closing note.
Yeah.
Sachin, do you want to any last few words, or we can close the session?
Yeah, I mean, if you are interested or excited about building on blockchains, you can. So I have already shared this presentation link in the chat. You can go through the blockchain resources over here, and just if you have any other questions, you can join, go to biconomy.io, join our Discord channels, and there we have like different channels, and you can ask any of your queries, be it Biconomy related or not. We would be happy to help you on your any blockchain related questions.